On the morning of July 4th, before dawn breaks, two worlds will meet in the eastern sky. If you step outside and look toward the eastern horizon, you will witness a close cosmic encounter. Mars will be clearly visible to the naked eye as a bright red point, while Uranus sits just next to it as a ghostly blue-green point of light. You will need binoculars or a small telescope to spot this ice giant, which will appear as a faint speck of dust next to Mars. Nearby, the bright stars of the Pleiades cluster will complete the scene, creating a beautiful celestial alignment. Subscribe to Deep Space Signal to track these distant bodies, and let us explore the universe together. This close alignment is a rare viewing opportunity, separating the two planets by less than half a degree, roughly the width of a full moon. To locate them, find Mars first, as it will be the brightest reddish object low in the east. Once Mars is in your view, look just to the north to find the faint, pale dot of Uranus. This meeting of iron and ice brings a nearby desert and a distant giant into the very same field of view. This cosmic event occurs in the constellation Taurus, rising in the east shortly before dawn. The Pleiades star cluster, also called the Seven Sisters, sits nearby to serve as a bright guidepost. The cluster appears as a small, tight group of blue stars that resemble a tiny dipper, and the proximity of Mars and Uranus creates a wide, contrasting field of view. For astrophotographers, this is a prime opportunity to capture the red planet, the ice giant, and the blue stars together. But even with simple binoculars, the visual difference between these bodies is clear. To get the best view, step outside around 3:30 in the morning, giving your eyes at least 15 minutes to adapt to the dark. Find a location with a clear view of the eastern horizon, staying far away from tall buildings and bright streetlights. Because the early morning sky is often calmer and clearer than the evening sky, atmospheric turbulence is reduced, making it less likely to blur distant planets. As you look east, the bright red light of Mars will be unmistakable as it serves as your anchor. From there, sweep your binoculars slightly north to bring the pale dot of Uranus into focus, connecting you directly to the outer solar system. Once you find them, you will see two very different worlds, representing opposite extremes of planetary physics. The first target, Mars, is a dry, rocky desert covered in red iron dust. Because this small world has a thin carbon dioxide atmosphere, it cannot retain heat, meaning surface temperatures can drop to a freezing -80 degrees. Its ancient landscape remains scarred by volcanoes and dry riverbeds, with the reddish hue coming from iron oxide, or rust, on the surface. Unlike the outer giants, Mars is a solid, rocky neighbor that we can actively explore. Crossing this boundary leads to Uranus, a completely different class of planet. As an ice giant, this massive world contains no solid surface. Instead, vast oceans of water, ammonia, and methane ice surround a small rocky core. A thick atmosphere of hydrogen, helium, and methane covers the planet, explaining its signature blue-green color. Methane absorbs the incoming red light, reflecting blue and green back into space to create the pale dot visible in your binoculars. Located nearly 3 billion kilometers from the Sun, Uranus is the coldest planet in our solar system, with atmospheric temperatures that drop to a lethal -224 degrees. When you look at them on July 4th, they will appear to touch, but this proximity is merely a product of our line of sight. Mars is only about 200 million kilometers from Earth, while Uranus is nearly 15 times farther away, sitting at a distance of almost 3 billion kilometers. The light from Mars takes 11 minutes to reach your eyes, but the light from Uranus has traveled for 2 hours and 40 minutes through the cold void of space before hitting your lens. This alignment is a cosmic illusion, a meeting of two worlds separated by a vast and silent gulf. The physical differences between these planets extend to their gravitational and magnetic properties. Mars is a small, low-mass world with a surface gravity that is only 38% of Earth's. Lacking a global magnetic field, its atmosphere remains vulnerable to the solar wind, which has slowly stripped away its lighter gases over billions of years. This absence of a magnetic shield explains why Mars transitioned from a warm, wet world to a dry, frozen desert. Today, it is a planet frozen in time, preserving its ancient geology under a thin blanket of carbon dioxide dust. Uranus, by contrast, is a giant with a mass 14 times greater than Earth's. It possesses a strange, off-center magnetic field, tilted at 60 degrees from its rotational axis, which causes the planet to wobble wildly as it rotates. A deep, superpressurized ocean of water and ammonia generates this magnetic field by acting as a liquid conductor. Uranus is also unique because it rotates on its side, rolling around the Sun with an axial tilt of 97 degrees. Consequently, each pole experiences decades of continuous sunlight followed by decades of total darkness, creating the most extreme seasonal variations in the solar system. The alignment on July 4th carries a historical twist. On the 4th of July, 1776, the founders gathered in Philadelphia to sign the Declaration of Independence. That night, if they had looked at the eastern sky before dawn, they would have seen Mars in this exact position. The physical laws of planetary orbits have not changed, and the same celestial cycles occurred eons ago just as they do today. But there is a fundamental difference in their understanding. For those historical observers had no idea that Uranus was even there. In 1776, our cosmic map was much smaller. For thousands of years, humanity tracked only the 6 classic planets, which were bright enough to see without telescopes. Because their paths had been recorded by ancient stargazers, the boundary of the solar system was believed to end at Saturn. Uranus remained invisible to the naked eye, a secret world in the dark outer solar system that no philosopher or scientist of the era knew existed. 5 years after the declaration, our cosmic map changed forever. In 1781, William Herschel discovered a new world while conducting a systematic sky survey. Using his home-built telescope, he noticed a faint, fuzzy object that did not look like a star. At first, Herschel assumed he had found a comet, but subsequent orbit calculations soon revealed the truth. It was a massive planet orbiting far beyond Saturn. This discovery instantly doubled the size of the known solar system. Herschel was not looking for a new planet that night. In March 1781, he was simply surveying double stars. He was using a reflecting telescope with a 7-inch mirror, which he had built by hand in his garden. During his measurements, he noticed a small, unusual object that showed a distinct disk under higher magnification. This led him to report it as a comet, but as other astronomers tracked its slow path, they realized the object followed a circular orbit far beyond Saturn. The discovery of this new world created a scientific sensation that spread quickly across Europe. As the discoverer, Herschel was granted a royal pension by King George III, allowing him to focus entirely on astronomy. In gratitude, Herschel proposed naming the planet Georgium Sidus, or George's Star, a name that was popular in Britain but rejected by the international community. The German astronomer Johann Bode proposed the name Uranus, following the classical tradition of mythological figures, and the name was slowly adopted, establishing the new boundary of our solar system. The discovery of Uranus was a critical moment in scientific history, representing a physical expansion of the human map. Previously, the solar system ended at Saturn with a radius of 1.4 billion kilometers. The addition of Uranus pushed that boundary to 3 billion kilometers. The universe had not grown, but the human perspective had, and this change was a profound shift in how we viewed the limits of our knowledge. Accepting these new limits changed everything. Astronomers realized the cosmos could contain large, invisible worlds that had remained hidden for centuries. This triggered a search for more planets, leading to the discovery of Neptune in 1846 and Pluto in 1930. As the map of the solar system continued to grow, it proved that our understanding is a work in progress. Observation tools have evolved over time, moving from simple glass lenses to modern space telescopes that can look deep into the outer solar system. Each new telescope brought these distant bodies closer to home. In 1776, the sky was a flat dome holding stars and 6 wandering worlds. Today, we know that space is three-dimensional, filled with gas giants, ice giants, and asteroids. When we look at Mars and Uranus today, we see physical destinations that we have visited with spacecraft. We have mapped their surfaces and studied their atmospheres, transforming the unknown into a defined scientific system. The expansion of the solar system boundary reshaped planetary science. Previously, astronomy was primarily a descriptive science that only tracked the paths of the classic planets. The discovery of Uranus proved there were gaps in our maps, initiating a systematic search for hidden bodies. This search was guided by the Titius-Bode law, a mathematical formula that predicted the spacing of planetary orbits. The law suggested a hidden gap between Mars and Jupiter, a revelation that sparked a coordinated search and led directly to the discovery of Ceres and the asteroid belt. These early discoveries prove that scientific knowledge constantly evolves, driven by new technology. Herschel's home-built telescope with its high-quality metal mirror revealed a world that had been invisible to the greatest observatories of Europe. This success showed that instrument advances drive scientific progress. Today, this principle continues to guide space exploration as we build larger space telescopes and launch robotic probes. We are driven by the desire to map the unknown, motivating us just like 18th century astronomers. This transition to direct exploration shows that scientific boundaries are temporary, and the ice giants, now subjects of active study, prove that the solar system is a dynamic laboratory. Human history changes constantly, but planetary orbits follow a silent schedule. Since 1776, the Earth has completed 250 orbits, while Mars completed 133. Meanwhile, Uranus completed just under 3 orbits. The vast distance and slow motion of these outer planets create immense cycles, establishing timelines that dwarf the lifetime of human nations. This difference in scales highlights solar system stability, where the same physical laws continue to guide the planets today. Gravitational forces between the sun and planets maintain these precise paths, keeping the celestial alignment on a predictable track. While human societies experience wars, technological shifts, and social changes, the planets continue their silent paths through the dark, indifferent to events on the small world below. This constancy makes astronomy a powerful tool for reflection. When we look at the alignment of Mars and Uranus, we see the same physical processes that occurred billions of years ago, motions that will continue long after we are gone. The sky is a natural archive preserving the motions of the early solar nebula. By observing these alignments, we connect to a larger cycle, finding a sense of stability in these regular movements. The orbits of Mars and Uranus share a common gravitational balance that maintains the entire solar system. The Sun contains over 99% of all system matter, exerting a dominant pull that keeps the planets in their elliptical paths. This gravitational equilibrium is stable over billions of years, preventing the planets from colliding or drifting into space. While minor perturbations occur as the planets pass near each other, these forces are too weak to disrupt the system, preserving the celestial clockwork. This stability is a product of solar gravity acting as a physical anchor for every planet. The mathematical precision of these paths was first calculated by Johannes Kepler, who showed that planetary motions follow strict geometric laws. These same equations govern the flight of modern spacecraft, allowing us to navigate vast distances with extreme accuracy, connecting historical mathematics to modern space travel. This permanent cycle contrasts with human geography. Since the 1700s, borders have shifted and empires have fallen. While the human population expanded across every continent, the cities we build are temporary structures, subject to weathering and decay, while the planets continue their silent paths through space. By tracking these orbits, we gain perspective on our place in time. The cosmic alignments link the past, the present, and the future, occurring with a regularity that transcends human history. The morning sky will offer a quiet moment on July 4th, before the holiday celebrations begin. The planets will display a silent light show before the fireworks fill the air. Step outside in the early hours before dawn, find a clear view of the eastern horizon, and look for the bright red light of Mars. If you have binoculars, trace the space next to it to find the faint dot of Uranus, and think about the vast distance separating these two worlds. This observation connects us with history and the cosmos. When you look at Uranus, you see a giant world that was invisible to the founders of the nation, remaining hidden until technology allowed us to see it. It is a reminder that there are always new worlds to discover and new boundaries to push. The same sky that looked down on the birth of the nation continues to offer new discoveries, showing that our journey of exploration is far from complete. We are grateful to our supporters whose help keeps Deep Space Signal active. If you want to support our work and help us create content, consider joining our Patreon page using the link below. If you could travel to one of these worlds, which would you choose? Would you prefer the deserts of Mars or the freezing atmosphere of Uranus? Let me know your thoughts in the comments, and let us continue to explore our cosmos together. To prepare for this observation, check the local weather forecast and look for a clear, cloudless sky. You do not need expensive equipment to participate, as a simple pair of binoculars will reveal the pale blue-green dot of Uranus. If you use a mobile sky map, apply a red filter to preserve your night vision. The process of searching the sky is rewarding, and adjusting your focus to find a distant ice giant is a great exercise in patience. Stand in the quiet dawn, joining a long tradition of sky watchers as you see the same stars that guided ancient explorers. This light traveled millions of kilometers to reach you, carrying the physical signatures of distant worlds. Soon, the morning sun will rise, and the planets will fade into the blue sky. Yet you will carry a new perspective, understanding the balance of iron, ice, and history. This celestial cycle links us across generations, offering a quiet moment of reflection. By looking up, we join a global community, finding wonder in the silent mechanics of the universe.